The conventions for scientific notation. How many numbers in front of the decimal place? 1. It always is represented as a to the power of n. A times 10 to the power of n, sorry. A times 10 to the power of n. Ella. If our value is less than 1, so an example of value that's less than 1 would be something like 0.00006. Is that less than 1?
Yeah.
I should have also written less than 1 and more than negative 1, but that doesn't matter. What does n equal? Or what must n be? So the power of n. What's our power when we've got a number that looks like that?
4.
Stop guessing. My advice would be face the front. That would be my first bit of advice. Second bit of advice is there's a really good desk in the front row that will help you capture information. Sam.
And then it'd be -4.
It would be -4. But what if it was like any, like I want a rule for any number. So what's n got to be? N's always,
A whole.
what type of number is it in that scenario? If my number looks like this, 0.00 something, it's always negative. Very good. Very good to stick by your convention despite the fact you're getting a bit of steering. If the original number is big though, our n value must always be positive. Our a value can be both positive and negative, correct?
Yes.
If my original value is a negative o, so let's say this was negative 0.0006, that would become negative 6 times 10 to the power of negative 4. Let's just check that 4 is good. The last convention is if we're unsure, what should we do? If we're unsure how to get the power right, what should we do? Physically count them, correct? We don't get ourselves into trouble. And we're always, what are we moving? The decimal place. So just think about it like you're moving the decimal place. If you ever get lost, we can physically do that. Sweet. Why do we use scientific notation? What's the reason? We're lazy, makes it easier, helps us represent really, really big and really, really small numbers. Cool? Alright, let's do some fun stuff. We're going to do a